Hello 108 students, welcome to section 7.3 here with you, Mr. McHugh, working on complex fractions. Going to tackle page 1 of our class notes, and we're going to work on simplifying complex fractions. There's two methods here that the book describes. When I've taught this before, I almost went batty with the book and their approach to doing this. That once you understand what method 1 is, what method 2 is, they tell you any of these complex fractions you could use either method. And I'm just telling you right now, I like to take the path of least resistance so that you can get success and not go bananas. So I recommend you follow my class notes here and follow the guidelines as to how to determine which method to use. That's the big thing here. Okay, so this page 1, we are going to work with method number 1. Now, and this is the same technique as the book here, so I mean as far as the naming convention. So method number 1 is going to deal with a format where you've got, now please listen, watch the words and watch how I have you read this. You have one rational expression up in the numerator, and how you tell you have one rational expression is you look for the fraction bar up in the numerator, and you see only one of them, that's one rational expression. Look at the denominator. When you see one rational expression, use method number 1. Okay, method number 1 is no different than back in the days when you have a regular fraction like 2/3 and you were asked to work that out. And how did you do that real quick? You took the numerator fraction and you multiplied it by the reciprocal, which was 3/2. Okay, now an intermediate step I hear was to, sorry, I'll show this to you, just 1/2 fraction bar, you put the division and you put the 2/3 if you want to show that intermediate step. A lot of you realize when you have a fraction divided by a fraction, you convert it to multiplied by the reciprocal, and that's method number 1. So you're familiar with the technique, you just got to get used to looking at rational expressions here. Okay, so that's the idea. Now look at my steps. Simplify the numerator and denominator, excuse me, and divide by multiplying by the reciprocal of the numerator. Simplify your result, 1, 2, 3. Okay, so let's get down here. Let's work an example. Use method number 1. I'll read this to you. When you have one fraction, one rational expression in each of the numerator and denominator. Again, that read is the fraction bar. Okay, so let's take a look at example 1. You have x plus 1 divided by x. Look for that big fraction bar. That's the division. So you've got a rational expression up in the numerator. Why is it only 1? How many fraction bars do you have? Only 1. I can't tell you how that advice, it took me a while to figure that out. I used to have people counting how many plus and minus signs. It was all wrong. Simply look for the fraction bars. How many do you have down in the denominator? 1. Use method number 1. Okay, what's method number 1 say? Take the rational expression in the numerator and divide it by the rational expression in the denominator. A lot of you will just go ahead and go straight down here and multiply it by the reciprocal. I took the x plus 1 is down in the denominator, and what was in the denominator, 2x, is now in the numerator. Okay, so you go, that's not so bad. And this is back from the previous section. You multiplied rational expressions, so there you go. Factor, that's the big thing here. So you have 2x times the quantity x plus 1. Putting those parentheses helps you see that. You've got x down in the denominator and x minus 1 in the numerator. That's what I showed here. Then you see 2x divided by x. The x's cancel out and you're left with 2. And my big question for you is, do you have the Texas flop here? Side flop. Okay, now if you just watched my video number 13, hopefully you're going to tell me what the answer is. Okay, I'm waiting for you. Hopefully you're saying no. Does this match the flop? Okay, it doesn't even come close. Do you have minus signs up in the numerator and denominator? No. Are the diagonal terms the same? No. So you leave it alone and you're done. Okay, make sure you see that Texas flop. It will save you a lot of time and aggravation. Okay, hey, Mr. McHugh here. I have finished page 1 with you guys. We have worked on method 1. When I see you for page 2, guess what method we're going to work on? Method number 2. Okay, so hope you're doing good there, and I'll catch you on the next video. Okay, bye.